Okay, section 8.3, hypothesis testing, testing a claim about a mean. In this section, this is a continuation of section 8.1, 2, and then a continuation of 8.2. In 8.2, we did testing, hypothesis testing, a claim about a proportion. Here, we're going to do testing a claim about a mean. These are the things you have to understand when we do testing a claim about a mean. There might be two different situations. The first one, if you don't know the standard deviation of the population, we use the t distribution, t value, for the test statistics. And if you do know the standard deviation, um, and population is normally distributed, or at least the sample size is greater than 30, then we use the g-score. Okay, and rest of the things, they are very similar to the things we did in previous sections. We, after finding the p-value, we compare with alpha, or we find the critical value and check either that is in the critical region or not. And to make the final wording, this is what we're going to use, this flowchart. And yeah, that's all. Okay, one more time, if you don't know the standard deviation for the population, then we use the t-score. And these are the requirements you have to keep in mind. The samples should be simple random. Either the original population should be normally distributed, or sample size should be greater than 30. In that case, the t-score can be calculated using this formula. We use either p-value or critical value. Even to calculate this thing, I'm going to use the StatCrunch, so you can use the StatCrunch. Okay, so for n is greater than 30, you have to keep in mind, if the original population is not itself normally distributed, then sample size has to be greater than 30. Sample size of 15 to 30 are sufficient if the population has a distribution that is not far from normal. And in this text, we use the simplified criteria of n is greater than 30, just to make things easier. Okay, and then you also have to understand about the student distribution, which we cover in previous chapter, and these are the important properties of the student distribution. After that, let's look at some problems from this section, and then I'm going to talk about different scenario here. First one, 12 different video games showing alcohol use were observed. The duration times of alcohol use were recorded. So this is the data we have given, 12 different data. And now, what requirement must be satisfied to test the claim that sample is from the population with the mean greater than 75 seconds? Other requirements are all satisfied. And these are the requirements: either the population is normally distributed, or n supposed to be greater than 30, or both. The condition for simple random, the samples observation must be simple random. So these are the two conditions. Are the requirements all satisfied? So if you check the data here, and then if you check the requirement, where is that? So the question is, what are the requirements must satisfy to test the claim that sample is from population with the mean greater than 75 second? So the requirement, if you go and check the requirement, the sample is simple random sample, either or both of these conditions are satisfied. The population is normally distributed, or n is greater than 30. So in this problem, we don't know either it's from greater than, either it's from normal distribution. So the requirement has not met here, so the answer is no. But you have to choose which one is no. No, the condition for the binomial distribution are not satisfied. The sample size is not greater than 30. The sample does not appear to be for a normal distribution population. There is no observation above 75. The sample size is not greater than 30. The sample doesn't appear to be from a normally distributed population, and there is not enough information given to determine. If you check the data here, as you can see here, if you do it in ascending order, sort the table, you can see it's going up to, no, it doesn't look like normally distributed data. It's just keep growing, right? So the condition is the last one, the sample size is not greater than 30. That's the first thing, and it does not appear like a normally distributed data. Okay, the claim is that weight in grams of quarters made after 1964, it's about the weight of the quarters, a mean equal to 5.67 gram as required by MINT specification. The sample size is 35 and the test statistics is negative 3.044. Use the technology to find the p-value. So technology means we are going to use, we're going to use a StatCrunch. So go to the StatCrunch. First, let's answer this question. The mean is equal to 5.67 gram. That's the null hypothesis. And then alternating is not equal to, use the technology to find, based on the result, what is the final conclusion? 5.67. Alternating hypothesis. What is the test statistics? Test statistics, it's already given negative 3. If you round it to the 2 decimal place, it's a negative 3.04. And then if you want to find the p-value, you can use the StatCrunch. You can go to the stat, you can go to the calculator and t-stat. Remember, the sample size is 35, so degree of freedom is 34, 1 minus 35. And then t-score is, negative 3 point. So you just replace that by negative 3.044, and that gives us the area under the curve to the left. And but the claim is, what is the claim? Look at here. The claim is the weight of the quarter made after 1964 have a mean equal to 567. So its alternate is not equal. So it's a two-tailed test. So you have to multiply this by 2 to get the p-value. So if you multiply this by 2 and round it to the 3 decimal place, it's at 0.002 times 2 is 0.004. So you find the area under the curve to the left of this test statistics, but because of this not equal two-tailed test, we have to multiply that area by 2. Okay, so don't forget about that. If it's just a left-tailed test, then you just copy the answer. But if it's a two-tailed, you have to multiply the area by 2. Okay, now because the p-value is 0.04, you compare that value with the alpha and you go to this, what is that? P-value is less than alpha. If p-value is less than alpha is 10%, p-value is 0.004. So if p-value is less than alpha, reject null hypothesis. So that's the first thing. After that, you have to use this thing to make the final conclusion. So let's read the question. Based on the p-value, there is, okay, so that's the final conclusion. So remember, you start the question, and then does the original claim contain the condition or equality? Yes, because you want to check that the mean is 5.67, and we reject the null hypothesis. So this one is the final conclusion. There is sufficient evidence to warrant the rejection of the claim. So there is sufficient evidence at a significance level 0.10 to warrant the rejection of the claim. Okay, so that's how you make the final conclusion, like in previous section. Let's go to next problem, question number 5. The claim is that for 7 a.m. body temperature of males, the mean is less than 98.6 degree Fahrenheit. So the original, the null hypothesis is mean is equal to 98.6. 98.6. Always the null hypothesis is equal. Alternating is less than, this case the alternating is the claim actually, less than 98.6. and now we have given for this to check this claim, we have a sample with the sample size 36 and test statistics, it's also given here, so it's a negative 4.42 if you round it to the 2 decimal place here. Now we need to use the technology to find the p-value. Keep in mind, this is the left tail test for finding the p-value. When you go to the StatCrunch and go to t-stat calculator, calculator, the degree of freedom in our case, in this case, is 35. The area to the left, we need to find the left area because it's a less than. For this test statistics, which is negative 4.42. So here negative 4.42, we need the left. That's why this less or equal sign is correct. And because it's just a left tail test, this is your p-value 0.0004. If you round it to the 3 decimal place, it will be 0. So the answer is 0. Since p-value is less than the significance level alpha, p-value is less than alpha, reject the null hypothesis. Reject the null hypothesis. So based on the p-value, there is, to make the final conclusion, you go here. The original claim is less than, so you go to this direction and reject the null hypothesis. So there is a sufficient evidence to support the claim. So p-value, there is sufficient evidence at a significance level. Let me double check. P-value is less than alpha, reject the null hypothesis. So if you reject the null hypothesis, there is sufficient evidence to support the claim. So there is sufficient evidence at a significance level 0.1 to support the claim that for 7 a.m. body temperature of males, the mean is less than 98.6. Let me do next question. A data set about speed dating includes like ratings of male deaths made by the female deaths. The summary statistics are: the sample size is 184, sample mean is 5.59, sample standard deviation is 1.95. Use a 0.05 significance level to test the claim that population mean of such rating is less than 6. Assume that simple random sample has been selected. So now, to solve this type of problem, first of all, we need to find the null and alternating hypothesis. The null hypothesis is equal to, the mean is equal to 6, and then alternating is less than 6. That's the claim, less than 6. So find out the mean equals 6 and less than 6. That's our hypothesis. For finding the test statistics for a problem like this, you go to the StatCrunch and go to the stat and then go to the t-stat and go to the one sample with summary and fill out this information. Okay, here we are trying to find the t statistics, so it's a t-stat. So sample mean, it's a 5.59, it's given. Sample standard deviation, that's 1.95, that is also given. Sample size is 184, that is also given. We need to check this hypothesis, the mean equal, null hypothesis is mean equals 6, and then alternating is less than 6. When you fill out all this information and then hit compute, it's going to give you the information you are looking for. Look at here. The t-stat is this value, negative 2.85. So that's test statistics, negative 2.85. And for the p-value, this is p-value, which is 0.0024. If you round it to the 3 decimal place, it's a 0.002. After finding the p-value, now you compare the p-value with the alpha, which is 5%. So p-value is less than alpha. That means reject the null hypothesis and make the conclusion based on this chart flow. So reject the null hypothesis. Remember, our claim is, what is the claim? Claim that population mean of such rating is less. So when you try to use this flow chart, you go to the left side because the claim is not equal and reject the null hypothesis. So this is the final conclusion. There is sufficient evidence to support the claim. So what is the claim? Reject the null hypothesis. There is sufficient evidence to conclude that mean of the population rating is less than 6. Reject the null hypothesis. There is sufficient evidence to conclude that mean of the population rating is less than 6. Okay. Okay, one more question. Assume that a simple random sample has been selected from a normally distributed population and test Where is that? Distributed population and test the given claim. Identify the null and alternating hypothesis, test statistics, p-value, and then state the final conclusion that addresses the original claim. A safety administration concluded crash test of child booster seats for cars. Listed below are results from those tests. So if you copy this data in the StarCrunch, you can get the data here. With the measurement given in HIC standard head injury condition units, the safety requirement is that the HIC measurement should be less than 1000 HIC. Use a 0.05 significance level to test the claim that the sample is from population with mean less than 1000. So alternate null hypothesis is equal to 1000 and then alternate is less than 1000. That's the for finding the t statistics and rest of the information. You go here and then use the stat t stat one sample with data. This time we have given data, so we select data and then we select this null hypothesis, which is 1000, and then alternating is less than 1000, and we just hit compute and it's going to give us everything we are looking for. The t statistics is negative 1.787. So if you round it to the 3 decimal place, it's a negative 1.788. That's a 3 decimal place. And then p-value, if you look at here, the p-value is the last value here, 0.0669. So 0.0669, 4 decimal place. And now compare the p-value with the alpha. Alpha is 5% and then p-value is 6%. So when you compare the p-value with the alpha, p-value is greater than alpha. Fail to reject. And if you go here to make the final conclusion, you go to the left side because the claim is less than, and fail to reject. So this is your final conclusion. There is not sufficient evidence to support the claim. So the answer is fail to reject. There is not. So that means there is insufficient evidence to support the claim that the sample is from population with mean less than that. Okay. And now, what do the results suggest about the child booster seat meeting the specified requirement? So if there is insufficient evidence to support the claim. So what is the claim? Claim is it's supposed to be less than 1000. So there is strong evidence that mean is less than no. The result are no. The result is made since most sample measurement are less than 1000. There is not strong evidence that the mean is less than 1000 HIC, and one of the booster seat has a measurement that is greater than 1000 HIC. Okay, there is not so what is the question? What do the results suggest? To test the claim that sample is from population with the mean less than 1000, do the results suggest that all of the child booster sets meet the specified requirement? No, there is not strong evidence that the mean is less than 1000, and one of the booster sets, if you look at the data, here, if you sort the data, you can see that one of the booster sets is greater than 1000. One of the booster sets has the measurement that is greater than 1000. Okay,